Alright, so in this video, we are once again going to calculate the accelerations of a couple points. Okay, so you've been given a rod that is pivoted at this point here, not point P, but like pivoted at this point. Let's call it O, and it's currently horizontal, and it's let go, and when it's let go, we're asking with what acceleration will it start to fall. Okay, so at that instant, what is the acceleration? And we'll see that this acceleration is actually going to change as the angle of the rod changes. But the first part we'll do is we'll find the acceleration at this point, and we'll see what it ends up being. Okay, but we're asking two questions. I'm asking what is the acceleration of the center of mass, and what is the acceleration of the point P. And by now, I hope you all realize that anytime something is turning, something is rotating, something is spinning, the acceleration or velocities of different points on the object will be different depending on how far they are. So here clearly center of mass is closer to the axis of rotation, so we expect the ACM to be less than AP. So let's calculate and let's see if this ends up being or not. So at this point, as usual, we'll draw a free body diagram. Okay, and there's not really much. There's only one force acting on this object, which is the force of gravity acting at the center of gravity, center of mass of the object. Okay, so that force we know is mg, and essentially that's the only force that's causing any kind of acceleration. So we will use our equation tau equals I alpha, and what we know is tau is simply equal to mg times L over 2, because L over 2 is the perpendicular distance from the pivot, and that is equal to I. Now this is a uniform rod of length L, and the moment of inertia about one end of the rod is 1/3 ml square, and we multiply all this by alpha. So this ends up telling us that alpha is equal to 3g over 2L. Okay, once I have this, now finding ACM is simply multiplying alpha by the radius, by how far the center of mass is from the axis, which happens to be L over 2. So we end up getting 3g over 4 for ACM, and for AP we end up getting alpha times L, which is 3/2 g. Okay, now it was a very simple problem, but let's take a slight variation of this problem, where we will instead have this rod be at an angle. We say that, hey, as it's falling, let's say that the rod is making some angle theta with the vertical. At this instant, what is ACM or AP? Okay, and let's calculate this. So what I'd like you to do right now is stop, or rather pause the video, and do the whole calculation, and then come back and see if your answer matches the correct answer. Okay, so I'm going to draw my force once again right at the center. It's going to be mg, and I'll find the torque. Now to find the torque, I need to know the perpendicular distance of my force from this pivot. So I need to know what this distance is. Now this distance can be found very easily. I know that the hypotenuse is L over 2, and so in order to find this distance, I will basically just need to use the angle theta here, and it's simply L over 2 times sine of theta. Okay, so I know my torque is mg times L over 2 sine theta, and this is once again equal to 1/3 ml square times alpha. This gives me alpha as 3g sine theta over 2L. Okay, and essentially this is as expected, because you see for the first angle theta was 90 degrees, and the theta is 90, sine of theta ends up being equal to 1, and we end up getting the first expression, which is 3g over 2L. Once again, I can find my ACM, and ACM is simply going to be equal to 3/4 g sine theta, and AP is going to be equal to 3/2 g sine theta. And I'm sure you can show each of these things by simply multiplying by the corresponding lengths. Okay, so that's hopefully this helps with this problem.